Start. This is new section in climatology. Atmospheric pressure and atmospheric pressure belts, then we have winds, and then tricellular meridional circulation model. And multiple questions are there from these three topics related with climatology. This is the second section in the climatology which are interconnected. Atmosphere, atmospheric pressure and atmospheric pressure belts, winds, tricellular meridional circulation model, and most of the questions are related with tricellular meridional circulation model and winds. Remember that these are the assumptions behind origin of pressure belts and winds. These are the assumptions. Means assumed conditions, ideal conditions, standardized conditions. First, first assumption we take uniformity on surface of Earth. Means surface is uniform without altitudinal differences, without distribution of land and water. Second, differential heating of Earth's surface with high solar insolation and surface and air temperature in low latitude and low solar insolation with surface and air temperature in high latitudes. That is source of potential energy. Differential heating of Earth's surface, particularly in assumed uniform surface of Earth, is source of potential energy with high solar insolation, surface and air temperature in low latitudes and low solar insolation, surface and air temperature in high latitudes. That is source of potential energy. On rotating surface of Earth, this potential energy change into kinetic energy. This kinetic energy is a source of circulation of air in atmosphere known as winds. Means a static situation is changing into dynamic situation with conversion of potential energy into kinetic energy, that is on rotating surface of Earth. These two assumptions are related with first law of thermodynamics. Now, fourth, friction is source of consumption of kinetic energy. Friction occurs between winds and surface as well as between the molecules of the winds. Yeah, circulating air. So energy is consumed. So there must be a balance between rate of conversion of potential energy into kinetic energy and rate of loss of energy through friction. So we are going to study distribution of atmospheric pressure belts, circulation of winds in lower troposphere as well as upper troposphere in following 4 idealized या assumed या presumed conditions. First, there is uniformity on surface of earth. That is an ideal situation. We are taking into account with this uniformity on surface of earth, there is generation of potential energy with differential heating of earth's surface. We have already studied there is high solar insolation with surface and atmospheric temperature in low latitudes, low solar insolation, surface and air temperature in high latitudes, that is source of potential energy. On rotating surface of earth, since earth is rotating, it is source of converting potential energy into kinetic energy, that is source of circulation of air. And finally, friction is source of consumption of kinetic energy. Kinetic energy is consumed during flow of winds through the friction. Friction occurs between the flowing winds over the irregular surface of earth as well as between the air molecules. So there must be a balance between rate of conversion of potential energy into kinetic energy and rate of loss of energy through friction. This will provide sustainability or consistency to air circulation. It is understood. Shall I start with the atmospheric pressure? Definition of atmospheric pressure. Remember that atmospheric weight on per unit surface of earth is described as atmospheric pressure. Like if this is a column of atmosphere, vertical column of atmosphere with thickness H, density D, covering an area A. So you know that atmospheric mass is going to be equal to volume into density. Mass is concentration of material in a given volume. So here volume is A into H. H is here thickness of atmosphere. Density is D. You know that atmospheric weight is going to be A into H into D into G. Weight is mass into gravity of Earth. Gravity is a centripetal force. So atmospheric pressure is atmospheric weight on per unit surface of Earth, that is divided by A. So atmospheric pressure is a function of thickness of atmosphere, density of atmosphere and gravity of Earth. It means that atmospheric pressure is directly proportional to density of air. Means as density of air increases, atmospheric pressure increases. Okay na? So you know that which are the factors affecting density. Remember that contraction of air, and compression of air. Both are responsible for increasing density of air. So in these two situations, pressure is going to increase. And how pressure declines? If there is expansion of air. With the expansion of air, density declines. So with the decline in air density, low atmospheric pressure is formed. It is understood? It is understood. Shall I go ahead? These are the basics of atmospheric pressure. Now, vertical distribution of atmospheric pressure. Vertical distribution of atmospheric pressure. Remember that this is sea level, altitude, normal atmospheric pressure. Normal means in a standardized situation at sea level is 1013.2 millibar. So with altitude, atmospheric pressure declines because thickness of air is declining with altitude. Air becomes thin and the thin air has low density. So as we travel distance from the sea level, atmospheric pressure declines. So at 5 km from sea level, atmospheric pressure is, normal atmospheric pressure is 540 millibar. These two figures are important. Normal atmospheric pressure at sea level 1013.2 millibar. Remember that in geography millibar is the unit of atmospheric pressure used. Like for temperature we use degree centigrade. Fahrenheit is no more used. Gram per centimeter cube is used for the density. These are the units used. Rainfall millimeter या centimeter depending on amount of rainfall and duration of rainfall. These are the units we are required to remember. None of the other unit is used. So understand a situation. If this is an air parcel and it is sinking from high altitude to low altitude. If there is an air parcel and it is sinking from high altitude to low altitude, means upper troposphere to lower troposphere. So what will happen? Since on this sinking air pressure is on rise, so it is going to be compressed. With compression, I have already taught you, density is on rise, concentration of heat is on rise, because air is poor conductor of heat. Air to air transfer of heat is poor. So this process, which is working on sinking air from upper troposphere to lower troposphere, is called dynamic compression and heating of air. Dynamic compression and heating of air. This dynamic compression and heating of air is not forming through the heat exchange between surface and atmosphere or atmosphere to surface. It is because of an same, this air parcel is rising up from low altitude to high altitude. So remember that the reverse process will set in. As the atmospheric pressure on this rising parcel of air declines, it is going to expand. This process is going to be called as dynamic expansion and cooling of air. Cooling of air, which is rising from lower troposphere to upper troposphere. You know that as air expands, it is going to increase in volume. Heat will be redistributed in larger volume. So remember that. Come to this. This dynamic compression and heating of air is source of high pressure with high temperature, and this dynamic expansion and cooling of air is source of low pressure with low temperature. Remember these two. Yesterday I taught you the temperature of an air mass could be changed by allowing outflow or inflow of air. This is another process that is called dynamic. In physics it is called adiabatic. In geography it is called dynamic. Remember the term dynamic. Dynamic compression and heating of air sinking from upper troposphere to lower troposphere, and dynamic expansion and cooling of air which is rising from lower troposphere to upper troposphere. So this is part of the basics which we have studied before we have studied the pressure belts. Shall I go to the pressure belts? It is understood? Atmospheric pressure belts. Belt here indicate latitudinal zones. If a phenomena is distributed along the latitudes within certain latitudinal zones, then that is described as belt. If a phenomena is distributed or circulating along the meridians, that is called meridional distribution. So here atmospheric pressure belts. So latitudinal zones with concentration of high pressure and low pressure are described as atmospheric pressure belts, and that is at the sea level. Of course, assumptions I have taught you. We are discussing atmospheric pressure belts in idealized situations, ideal conditions, ideal context. We are not taking into account distribution of land and water, altitudinal differences on surface of Earth. So latitudinal zones with concentration of high pressure means higher than the normal atmospheric pressure. Concentration of low pressure, pressure is lower than the normal, are described as atmospheric pressure belts. And these are atmospheric pressure belts. We need to make two diagrams. Remember that atmospheric pressure belts and the winds are interconnected. This atmospheric pressure belt, which is distributed from 5 degree north to 5 degree south, is called equatorial low pressure belt. It is on the either sides of equator 5 degree north to 5 degree south. And location of equatorial low pressure belt within the equatorial belt occur while the midday sun is overhead on equator. These pressure belts are located in this manner while midday sun is overhead on equator. Then equatorial low pressure belt is located within equatorial zone. Most importantly, from 5 degree north to 5 degree south. Another pressure belt is polar high pressure belt. I am giving them same color because the processes involved in generation of equatorial low pressure belt and polar high pressure belts are same. Those are known as thermal processes. They are not product of the dynamic processes. Then (25° to 35° in both hemisphere. We have subtropical high pressure belts. We have subtropical high pressure belts. Then 45 degree to 66.5 degree. 45 degree to 66.5 degree. In both hemispheres, we have subpolar low pressure belt. So there are 7 pressure belts distributed on surface of Earth. Equatorial low pressure belt, subtropical high pressure belts, because one of the subtropical high pressure belt is in northern hemisphere, another is in southern hemisphere. And that is their latitudinal distribution, while we keep midday sun overhead on equator. It means that these pressure belts are going to be modified, shift northward and southward while summer and winter solstice occurs. These are also going to be modified with altitudinal differences. These are also going to be modified with uneven distribution of land and water. But this is the ideal condition. Another diagram, since it is showing the static view of distribution of atmospheric pressure, it is not taking into account the flow of air, because I have already taught you in assumptions, potential energy changing into kinetic energy, that is source of air circulation within the troposphere, that is also involved into the formation of the winds and the pressure belts. So we need to have another diagram. This is 0 degree, 30 degree, 60 degree and 90 degree. I am not writing north and south, it means that it will include both of the hemisphere. Midday sun is overhead on equator. This diagram will again come while we are going to study tricellular model. This is your equatorial low pressure belt. I am going to change the color. Polar high pressure belt, subtropical high pressure belt, subpolar low pressure belt. These winds are called trade, westerlies and polar easterlies. This circulation in form of the cells are known as, this is called Hadley cell or tropical cell. This is called Ferrel cell, polar front cell, and this is called polar cell. C means cell. 0 to 30 degree we have Hadley cell tropical cell, 30 to 60 degree we have Ferrel cell polar front cell, and 60 degree to 90 degree in both hemisphere we have polar cells. This upper tropospheric flow in the Hadley cell is called anti-trade, because its direction of flow is opposite to the trade which are flowing in lower troposphere. These are called anti-trade. Remember that unless until tricellular model is over, this topic is not going to complete. We have to begin from somewhere. We are starting with the pressure belts, then the winds, and then the tricellular model. Then the entire picture will come. Topic on the winds are the next. But I am giving you the broader view, so I have to give you the entire picture. This is called integration. If you integrate geography, syllabus is going to be short. because 2 to 3 topics are basic, rest of the topics are based on the variables we have studied in 2 to 3 topics. So understanding the process of integration and interlinkages is very important. If you do not understand, so again in the market there is a hawa that geography is too extensive. None of the optional is limited and restricted. Now, on the basis of origin, pressure belts are classified into 2 categories: thermally originated and dynamically originated. On the basis of origin, these 7 pressure belts, I am including the entire surface of Earth, both of the hemisphere, are classified into 2 categories: thermally originated and dynamically originated. Now, thermally originated atmospheric pressure belts. Are equatorial low pressure belt and polar high pressure belts are thermally originated. Why these are called thermally originated? Their origins are related with thermal properties of the surface. Thermal properties of the surface. Now, I am discussing equatorial low pressure belt. This is midday sun overhead on equator on 21st March and 23rd of September. So in equatorial region, 5 degree north to 5 degree south, there is high sunshine as midday sun is overhead on equator. So on either sides of equator, 5 degree north to 5 degree south, sunshine is high. So there is going to be high surface and air temperature. I have already taught you surface temperature is source of air temperature. Surface heating is source of air heating. So there is flow of heat from the surface to air. So there is going to be thermal expansion of air with surface heating. That is called thermal heating and expansion of air above equatorial surface. So here exists high temperature with low atmospheric pressure in equatorial zone. Getting this thing? There is high solar insolation with high surface and air temperature in equatorial region. while the midday sun on 21st of March and 23rd of September is overhead on equator. So there is thermal heating and expansion of air. With the expansion of air, air density declines. Getting this thing? So in equatorial zone, we have high solar insolation with high surface and air temperature coexisting with low atmospheric pressure. Getting this thing? Now further, this hot, humid and lighter air is source of convective rise. Vertical rise of air is called air current. Horizontal movement of air is called wind. I am coming on. So there is thermal convective rise of hot and humid air current. Hot, humid and lighter air current, which creates a situation of calmness. Yeah, windless. Situation of calmness या windless. That is why equatorial low pressure belt is also called doldrum. Because of this one. Thermal convective rise of strong, hot, humid and lighter air current. There is absence या near absence of wind. So that becomes zone of calm या doldrum. Remember that I have already taught you in a system of constant mass. Since in equatorial zone hot, humid and lighter air is rising, so that has to be compensated with inflow of winds on either sides from high latitudes to low latitudes. These winds are known as northeast trade, white trade, that will explain in the winds, and southeast trade. This is logical sequencing and logical consistency and sequencing. This logical sequencing is important. First, I have explained atmospheric low pressure in equatorial zone. That is source of rise of strong, hot, humid and lighter air current known as doldrum. Because of windless condition या zone of calm. This rise is supported by inflow and convergence of northeast trade and southeast trade from high latitudes to low latitudes. This is known as ITCZ, intertropical convergence zone. Intertropical convergence zone. So remember that northeast trade and southeast trade are transporting moisture from high latitudes to low latitudes. That is why ITCZ is loaded with the moisture. And presence of ITCZ is source of heavy rainfall. So we can say heat is transported from low latitudes to high latitudes by the doldrum, and moisture as a compensation is transported from high latitudes to low latitudes in lower troposphere. So this segment of Hadley cell is clear. First, understand equatorial low pressure belt. There is high solar insolation with high surface and air temperatures. Surface heating is source of air heating. there is thermal heating and expansion of air. So high atmospheric temperature occurs with the low atmospheric pressure. This hot, humid and lighter air is rising in form of thermal convective strong currents, that is known as doldrum या zone of calm या windless situation, that is outflowing in upper troposphere from low latitudes to high latitudes. I have already given known as antitrades. So if this air is rising and outflowing in the lower troposphere, it is supported and compensated by inflow of northeast trade and southeast trade from high to low latitudes, and that inflow and convergence is known as intertropical convergence zone. It is clear? So this transportation of heat in the lower troposphere is compensated with transportation of moisture. Now, polar high pressure belts. These are located in polar regions on Arctic and Antarctic. You know that in polar regions there is extremely low solar insolation because of tilt is too high. Tilt of solar insolation is too high. Midday sun is never overhead northward of Tropic of Cancer and southward of Tropic of Capricorn. So, surface and air temperature are extremely low. So that is source of thermal cooling and contraction of air. Thermal cooling and contraction of air. And you know that with cooling and contraction, high atmospheric pressure is formed. So in polar regions we have low surface and air temperature occurring with high atmospheric pressure. With thermal cooling and contraction of air. It is clear? And remember that this is 90-degree polar high pressure belt. You know that the denser air is sinking. So there must be dense air sinks. There must be outflow of the wind from the polar regions in both hemispheres. Those are called polar easterlies. Cold and denser air sinks in polar regions because of thermal cooling and contraction. As it sinks, it has to outflow. And that outflowing wind is known as polar easterly. Now, dynamically originated pressure belts. Remember that equatorial low pressure belt has high temperature, low pressure. high surface and air temperature occurring with low atmospheric pressure. Polar high pressure belts, low temperature with high pressure. Now let us see this one and this one. Which is colder? Which is hotter? Between these two, 60 degree or 30 degree? Which is hotter? 30 degree is hotter or 60 degree hotter? 30 degree. But here we are saying subtropical high pressure belt. It means that here high temperature occurs with high pressure, and here subpolar low pressure belt. Low temperature occurs with low pressure. It means that these two pressure belts are disconnected with thermal properties of the surface. So their origin cannot be explained by the thermal processes. Their origin are explained by dynamic processes या circulation of air. So I have already given you diagram. In subtropical region, air is sinking from upper troposphere to lower troposphere. Air is sinking from upper troposphere to lower troposphere due to the air circulation. Diagram is given. Potential energy is changed into kinetic energy, supporting air circulation. As air circulates, it sinks from high upper troposphere to lower troposphere. Flow in form of winds in lower troposphere and upper troposphere. It rises from lower troposphere to upper troposphere. Getting this thing? This sinking air is dynamically compressed and heated. In subtropical zones. So sinking of air from upper troposphere to lower troposphere due to the air circulation is source of dynamic compression and heating of air. So here is formation of high temperature with high pressure, and subtropical high pressure belts are also described as horse latitude. So remember that in the presence of subtropical high pressure belts, as air is sinking from upper troposphere to lower troposphere, rise of air from lower to upper troposphere is suppressed, restricted. Later on we are going to study. We have tropical deserts in subtropical high pressure belts. Since air is sinking, and as air is sinking, it has to outflow in lower troposphere. These winds are known as trades and westerlies. Winds which are flowing from high to low latitudes are known as trades, and from low latitudes to high latitudes from subtropical high pressure belts are known as westerlies. It is clear? So subtropical high pressure belts are source of trade winds and westerlies. As air circulates, there is sinking of air in subtropical zones from upper troposphere to lower troposphere. As this sinking air is compressed because of increasing pressure, there is rise of air density, there is a rise in concentration of heat producing high pressure with high temperature known as horse latitudes. Now, subpolar low pressure belt. Remember here, air is rising here. It is not rising because it has been heated. I told you, polar easterlies originate from polar high pressure belts. Westerlies originate from subtropical high pressure belts. So as westerlies and polar easterlies converge, so their kinetic energy, winds have kinetic energy with the horizontal flow. Mass they have, speed, velocity they have. Their kinetic energy is changed into potential energy. This conversion of kinetic energy into potential energy is source of rise of the air from lower troposphere to upper troposphere. This is subpolar low pressure belt I am explaining. So here is dynamic, expansion and cooling of rising air. Because of kinetic energy changing into potential energy. So it is according to first law of thermodynamics or not. One form of energy changing into another form of energy. Potential energy changing into kinetic energy changing into potential energy. So here low temperature occurs with low pressure in subpolar low pressure belts, which are relatively high temperature compared to the subtropical regions. And subpolar low pressure belt with convergence of westerlies and polar easterlies are also described as polar front. Why front? Here there is contrast in thermal contrast in westerlies and polar easterlies. Westerlies are hot and humid, polar easterlies are cold and denser. Polar easterlies are coming from polar regions, polar high pressure belts. They are going to be cold and denser. Westerlies are transporting heat from low latitudes to high latitudes. In latitudinal heat budget, I had already taught you. So with contrasting thermal properties, zone of convergence of westerlies and polar easterlies are described as polar fronts. Westerlies and polar easterlies have contrasting thermal properties. There is contrast in temperature, there is contrast in their temperature, their density. So because of this contrast, this zone is known as polar front. Remember that this contrast is absent in equatorial region because northeast trade and southeast trade both are flowing from high latitudes to low latitudes. Both are hot and humid. That is why the view that ITCZ is also a front is discarded. It is clear? So these are our pressure belts. Shall I go ahead? Shall I come to the winds? Winds. There are two terms, air currents and winds. Thermal convective rise of hot, humid and lighter air is called air current, and its example is doldrum. Now, wind. Horizontal flow of air is described as wind. Horizontal flow of air is described as wind. So, there was a question in recent years. $54. थोड़ा एक छोटा सा चाय बोल देना बाबू. Discuss the forces which govern the air movement on the Earth's surface. So, the process and force behind rise of the air movement, vertical rise of the air, I have already described. That is thermal convective rise of hot and humid and lighter air, that is called air current. Now, the forces governing the movement of winds we have to describe. It is of 20 marks. Take 2 minutes break. Break ले लो 5 minutes. I'll have tea and then teach. No? So it is well known fact that the geography cannot be suitably taught with the online classes. That is just joke. Geography is semi-scientific. But these people will have the chances to revise also. Like these people are offline only. So they can come to the class and discuss. कहीं ना कहीं से तो शुरू करना ही पड़ता ना. Coachings are closed. Offline classes are not running. And I have taught these things are also part and parcel of the GS module. So I have asked them to allow these students of optional to attend the GS module class. Optional students are going to be provided to GS module class taken by me, geography, on geography. I have talked to them. So all these things are part of the basics also. So if there is some deficiency in your understanding, so there you can have the clarity with the revision. All the optional students of geography are going to be allowed to attend the GS module class without paying any extra money. It is understood by you people. Today I was talking to them to give them GS module class. Let us start. Start हो गया? So, discuss the forces which govern the air movement. Means we have to take into account vertical rise of hot, humid and lighter air. So you can make a diagram like thermal convective rise of hot, humid and lighter air currents for this. Horizontal flow of air is called wind. So we have to discuss speed of wind and direction of wind. And remember that direction of a wind is always known by its source. Like if wind is originating from north flowing to south, it will be called northerly wind, southerly, northeasterly, easterly, southeasterly, southwesterly, westerly and northwesterly. So a wind is never described in respect of its destination, in respect of its origin. And these are the forces governing movement of winds. First, pressure gradient force. Second, forces generated by rotation of Earth. I have already taught you in assumptions. Potential energy change into kinetic energy with rotation of Earth. And third is friction. So movement and direction of winds are governed by these three forces. Pressure gradient force, forces generated by rotation of Earth known as Coriolis force, and centripetal force. And friction is generated by surface. Shall I go ahead? So winds are governed, means movement of winds in respect of their speed and their direction are governed by these three forces. Pressure gradient force, then Coriolis and centripetal force generated by rotation of Earth, and third is friction. Pressure gradient force. Remember that initial speed and direction of a given wind is generated by pressure gradient force. And distribution of atmospheric pressure is indicated by lines known as isobars. I am drawing the isobars like this is 1020 millibar. This isobar could be part of either subtropical high pressure belt या polar high pressure belt. Getting this thing? According to the pressure belt, of course. And another is 1000 millibar. It could be part of either equatorial low pressure belt या subpolar low pressure belts. And these are 2 kilometer apart. Another situation, it is 1030 millibar, 990 millibar, and these are 0.5 kilometer apart. So remember that movement of a wind in every situation is always from high concentration of air या high pressure to low pressure. High atmospheric pressure to the low atmospheric pressure. Now, definition of pressure gradient: rate of change of atmospheric pressure is described as pressure gradient force. So what is pressure gradient force for situation A? This is situation A. That is 1020 millibar minus 1000 millibar by 2 kilometer. That is 10 millibar per kilometer. . and now I am writing speed S1. What is pressure gradient for situation capital B? Second one. Rate of change of atmospheric pressure is described as pressure gradient. Rate of change is described as gradient. That is 1030 minus 990 millibar by 0.5 kilometer. So that is 80 millibar per kilometer. This is speed S2. So which wind is going to have greater speed? Speed of S2 is more than S1 because pressure gradient force of situation B is more than pressure gradient force of situation A. Means S2 is going to be in term of speed 4 times greater than the situation A. Here pressure gradient force is 80. 40 है ना? हाँ ठीक तो है 0.5. No, 8 times. It is 8 times. It is 80 millibar. And under influence of pressure gradient force, the movement of wind is from high pressure to low pressure and at the right angle of isobars. The angle between movement of the wind and the isobars in these two situations are 90 degree. So with the pressure gradient force, which is the rate of change of atmospheric pressure, movement of a wind is always from high pressure to low pressure. As the pressure gradient increases, speed of the wind increases. Rate of change of atmospheric pressure is described as pressure gradient and the initial movement of the wind is right angle to the isobars under influence of pressure gradient force. Shall I go ahead? It is understood? Next is forces originating from rotation of Earth are known as Coriolis force and centripetal force. Coriolis force is responsible for deflection of winds. Remember that rotation of Earth itself is not responsible for origin of winds. Winds are always originating under influence of the pressure gradient force. Then they come under influence of the rotation of Earth and related forces like Coriolis force and centripetal force. Remember that deflection of winds in northern hemisphere is right hand side from the source and in southern hemisphere is left hand side from the source. And amount of deflection again from the source is directly proportional to sine theta. Theta is here latitudinal value, and you know that ki sine 0 is 0, sine 90 is 1. Means amount of deflection increases from low latitudes to high latitudes in both hemispheres, from equator to poles. Means as a wind is flowing from equator to poles, deflection is going to increase, and a wind is coming from poles to equator, amount of deflection is going to decline. This year this question was there in prelims. It is clear? So remember that northerly and southerly winds flowing between pressure belts originating under influence of pressure gradient force working between the pressure belts, like polar high pressure belt. This is polar high pressure belt, subpolar low pressure belt, subtropical high pressure belt. This is your equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt, polar high pressure belt. Under influence of the pressure gradient force, these winds are going to be northerly and southerly on the basis of their origin, flowing between the pressure belts under influence of the pressure gradient force. Greater is the pressure gradient, stronger is their speed. It's like this is, you have said, northerly wind flowing from subtropical high pressure belt to equatorial low pressure belt under influence of pressure gradient force. Coming under influence of deflection generated by Coriolis force, it will become northeasterly, since amount of deflection is low in low latitudes. This is southerly wind in southern hemisphere flowing between subtropical high pressure belt to equatorial low pressure belt, it will become southeasterly. This is a southerly wind. It is flowing from subtropical high pressure belt to subpolar with amount of deflection high, that will become westerlies. This is a northerly wind with amount of deflection high, it will become polar easterlies. Same way here, westerlies. And this is polar easterlies. See the number of diagrams we are constructing in the class. Same amount of diagrams, same number of diagrams you are supposed to construct in your copy. Geography, geospatial. If you dislike diagrams, maps and sketches and the charts, you should quit geography as an optional. How many people like geographical representation of the phenomena? तुम लोग कम्युनिकेट भी नहीं करते हो. आगे चले. It is clear. So northerly and southerly winds flowing between the different pressure belts originating under influence of the pressure gradient force are going to deflect it according to these rules. Right hand side in northern hemisphere, left hand side in southern hemisphere from their source. And amount of deflection is on rise in from low latitudes to high latitudes. That is why in high latitudes we have westerlies and polar easterlies. In low latitudes we have southeast trade and northeast trade. Low latitudes, low deflection. Now centripetal force. Centripetal force is source of providing curvature to a wind flowing under influence of pressure gradient force and Coriolis force. And curvature is always in the direction of deflection. There is no linearity in the flow of wind. Winds follow a curved path under influence of rotation of Earth and related centripetal force. So I am showing here curvature, you see here. Curvature is always in the direction of flow. It is clear? Shall I teach friction? Now friction. Friction is a restrictive force on the winds. And most importantly, it is generated by surface irregularities. And through the process of friction, energy is consumed. Kinetic energy of the winds are reduced. Rotational energy in the cyclones are reduced and consumed over the period of time. So remember that change in winds generated by friction are largely dependent on localized surface irregularities in form of landforms, human structures, but these are the conditions important for geography. Friction is high over continental surface compared to oceanic surface. And with altitude, friction declines. Means in upper troposphere, friction is less compared to the lower troposphere. That is why if we see the movement of winds at different altitude, with the declining friction, the speed of upper tropospheric wind is going to be greater than the wind flowing into the mid troposphere. The wind which is flowing into mid troposphere speed is going to be greater than wind which is flowing into lower troposphere close to the surface. So a force is generated because of differential movement of winds at different altitude, that is called wind shear force. Wind shear force. If the forces are working along a plane, due to the change in direction या change in movement, so that is called shear force. So a wind which is flowing in upper troposphere, and later on I will teach, when I will be teaching you geostrophic winds, jet streams and Rossby waves. This topic will, this context will come into account. So this way we have covered the wind. Shall I teach types of winds? Two minutes break. चाय पी लो. चाय पी लेता हूँ. I am saying that you people will allowed to attend the GS geography class taken by me. I have talked to them today so that your basics are repeated. Now, types of winds. उसके पहले कुछ बेसिक्स बता दो. Continental surface, oceanic surface. Remember that east coast of a continent is always western margin of an ocean. Like east coast of Asia and Australia are western margins of Pacific. It is very important. And west coast of a continent is eastern margin of an ocean. Like west coast of Europe and Africa are eastern margins of Atlantic. Like east coast of India is western margin of Bay of Bengal, and west coast of India is eastern margin of Arabian Sea. ये ध्यान में रखना. So if a wind is flowing from oceanic surface to continental surface, that is called onshore. And that is source of transfer of moisture From oceanic surface to continental surface, cloud and rain. In geography, these are described as inflowing onshore winds. Because we are studying winds, so their characteristics have been also asked. Properties. And one of the property of a wind is transporting heat, transporting moisture, clouds and rain, supporting hydrological circulation या circulation of water. Got it? तुम लोगों को अच्छा नहीं लगता है क्या ज्योग्राफी पढ़ना? बोलते बोलते हो नहीं या इनिशियली शॉक्ड हो? So remember that from the very beginning you people are up to the level of UPSC. It is not that I am going to give you any leverage so that I can make you fool. I am doing nothing from my own side. I am not making this syllabus and question paper stuff. I am doing something which has been given to us by UPSC. Honestly. Not 1% less, not 1% more. If the flow is in opposite direction, from continental surface to oceanic surface, those are called offshore winds. Those are described as offshore winds, and offshore winds are dry. So if there is a place throughout the year under influence of onshore winds, so rainfall is going to be throughout the year. If it is under influence of onshore winds in a given season, so that is going to have seasonal rainfall. And if a place is under influence of offshore winds throughout the year, so it is going to be dry and desert. Means the moisture contained by onshore wind and duration of the onshore wind determines moisture, amount of moisture transported, cloudy conditions and amount of rainfall. ये तो याद रह जाएगा ना. Amount of moisture in onshore winds and duration of onshore winds determines moisture inflowing to a place, cloud inflowing to a place and the amount of rainfall received by a place. Now, winds are classified into three categories. On the basis of their geospatial and temporal scale. Temporal means duration of time of flow. Geospatial means geographical expansion. Primary winds, these are also called planetary winds. Yeah, permanent winds. Then secondary winds, yeah, seasonal winds. These are also described as periodic winds. And then tertiary, yeah, local winds. Primary winds are doldrum. It is a convention to keep primary winds. It is convention to keep doldrums among the primary winds. Then trade winds, westerlies, and polar easterlies. These are primary winds. First, I am focusing on the primary winds because pressure belts with the primary winds are part of tricellular model, on which questions are multiple in nature. Diagram to I have already given. I am giving dictation. There are three terms: primary winds, those are also described as planetary winds, and permanent winds. I am defining primary winds. प्राइमरी का मतलब होता है प्राइमेसी, डोमिनेंस. These winds have primacy and influence over flow of secondary and tertiary winds. ठीक है, that is why primary wind, these winds are called primary. Planetary winds. Primary winds are also described as planetary winds. As with pressure belts, these winds cover nearly entire surface of Earth. Planetary means what? Something which is covering nearly entire planet Earth. Now, permanent. These winds have near consistency in direction of their flow. Means their flow is not changed according to seasons या according to day and night. Moreover, they have uniformly flowing, means their flow of direction is uniformly distributed throughout the year. Moreover, now describe them. Doldrum. Doldrums are strong thermal convective air currents. Thermal convective air currents. You are not required to write here in the mains examination what is air current. These are hot, humid, and lighter air currents loaded with moisture These are source of generating rainfall. In equatorial region between 2 p.m. to 4 p.m. because then the thermal convection is strongest. I have already taught you. Surface and air temperature is greatest between 2 p.m. to 4 p.m. even though solar insolation is greatest at 12 p.m. midday. The thermal convection is going to be stronger, so the rainfall. Trade winds. Trade winds outflow from subtropical high pressure belts to equatorial low pressure belts. Equatorial low pressure belt. These are described as northeast trade, in northern hemisphere and southeast trade in southern hemisphere. That diagram I have already given. Next point. Trade winds transport moisture from high latitudes to low latitudes. And they are the major source of providing moisture to ITCZ and doldrum, intertropical convergence zone and doldrum. Consistency in their flow is the region behind these are being called trade. In pre-modern period, these winds were source of navigation and oceanic trade because of consistency in their flow. आगे चलें. Westerlies. Westerlies flow from subtropical high pressure belt to subpolar low pressure belts. These are source of transportation. These are source of transportation of heat and moisture. Westerlies are particularly strong in southern hemisphere, particularly strong in southern hemisphere as they flow over vast and extensive oceanic surface. Vast and extensive oceanic surface. This. Here these are known as roaring 40s, at 40 degrees south, furious 50s at 50 degrees south, and shrieking 60s at 60 degrees south. Now polar studies. Polar studies flow from polar high pressure belts to subpolar low pressure belts. Their flow is prominent during winter season. These are cold, dry, dense, and source of heavy snowfall. Particularly during winter season. Okay, na? Now secondary and tertiary winds. Thank you. It's about time. Secondary या seasonal या periodic winds. These winds, I am teaching them. These winds change their direction of flow. Secondary या seasonal या periodic winds. These winds change their direction of flow. Either according to day and night, या according to season. That is why these are called secondary winds या seasonal winds या periodic winds. Their names are land and sea bridge, mountain and valley bridge, and monsoon. Remember that monsoon we are going to study in detail in Indian geography, because certain parameters and variables from structure and physiography are important to us, which describe distribution of monsoon rain in India, northeast monsoon and southwest monsoon winds. So in detail we are going to study in Indian geography. 3 topics we are going to study in detail in Indian geography. Write down: geostrophic winds, jet streams, Rossby waves, ROSSBY, and monsoon. These are interconnected. So even if I teach monsoon here, that is going to be partially covered. Even I teach jet streams, role of jet streams, we have to study in origin of monsoon winds. So we won't be able to cover entirely. It is clear? 4 topics of climatology we are going to study in Indian climate: geostrophic, jet streams, Rossby waves, and monsoon. मैं डस्टर ढूंढ रहा था, मुझे लगा डस्टर कहाँ है. Now, land and sea bridge. This is land surface, this is sea surface, this is your coast. So tell me one thing. If I am taking the daytime, which is going to be overheated, land or sea? So remember that in daytime, with the high solar insolation, there is overheating of land surface. Compared to the land surface, oceanic surface is cool because of slow heating of oceanic surface, slow and gradual heating of oceanic surface or water surface. So remember that with thermal heating and expansion of air, low pressure is forming over continental surface, and thermal cooling and contraction of air, high pressure is forming over oceanic surface. So wind always flow from high pressure to low pressure. So that is described as sea breeze. So coastal regions are under influence of sea breeze during daytime, like Mumbai, Kolkata, Chennai. And sea breeze is cool and moist. That is also a source of cloud and rain. That is why there is moderation in temperature during daytime of Mumbai, Kolkata, Chennai. That is why cost of living in Mumbai, Chennai and Kolkata is lesser compared to Delhi. Delhi is overheated during summers and shivering during the winter. So here cost of living is high. Delhi has continental climate. Mumbai, Chennai, Kolkata has marine influence. That is why people go to the Juhu Chowpatty. Someone is from Mumbai and all that, coastal region. Anyone in this class? No. Someone from Goa? Who is from Goa? No one? Maharashtra? Surat? Getting this thing? Now comes the night time. So remember that sea breeze is onshore. This onshore breeze could be used for sailing towards the coast from the sea. Most importantly, fishermen, boatmen, steamers. Their onshore sailing is most importantly during daytime, because sailing is easier. That is according to the wind. Night time, you know that if this is night time, land is cold, sea surface is warmer. Land is cold because of the rapid cooling. If the heating is rapid, remember that cooling is also going to be rapid. That is why it is considered that if the people are angry even at small things, they are considered as good people. They ventilate their anger easily. They do not allow their anger to accumulate it. Ventilation of the sadness, anger, frustration is important for psychological health of the person. Like people are ventilating their anger in old Rajendra Nagar. That is good for their mental health. The situation is sad, but excess of anything is bad. Shall I go ahead? So we have high pressure through the thermal cooling and contraction of air above cold continental surface या land surface and low pressure over warm oceanic surface. So wind is flowing from continental surface to oceanic surface, that is called land bridge. And land bridge is offshore. Okay na? So fisherman, boatman prefer to go to the sea for the sailing or for the fishing during night time, taking help of the land bridge. It is not that in night fishes are sleeping. You people must be remembering the time of the Mumbai attack. That was in the evening. Those terrorists took the help of the onshore wind to sail faster towards the Mumbai coast. They landed on the coast in the evening. Their boat was helped by this, motor boat was helped by the sea bridge. It is clear? Land and sea bridge. आगे चले? And remember that this periodicity of land and sea bridge and related moisture transportation, cloud and rain by the sea bridge is source of reducing pollution in cities like Mumbai, Kolkata and Delhi. We don't have in Delhi land and sea bridge. Land and sea bridge flowing across the coast, Mumbai, Chennai, Kolkata, they help in reducing air pollution, suspended particulates. So geography has its say in destiny of cities, towns, settlements, man, plants, animals, their habitats. इसीलिए लोग बोलते हैं आदमी के जिंदगी में या किसी के भी जिंदगी में समय और स्थान का महत्वपूर्ण योगदान होता है. प्लेस and time. If you are a right person, but the place and time are wrong, your destiny is going to be restricted. Like Vinesh Fogart. It is the fault of the coach to monitor the weight of the weightlifters and the wrestlers. Sad nahi hai. This is a matter of negligence. We Indians with the success develop complacency. Don't mind it. It is a matter of concern. Indian officials, Indian managers, Indian coaches, even the players could be so complacent. With so much money invested on them, national resources. $100 weight could be easily managed. Even with the drinking water, या not allowing drink of the water, या food, या dinner, या something. Like you have taken lunch before the measurement of your weight itself and you just deny the lunch. $100 could be managed. तुम लोगों को मेरी ये सब बातें बुरी तो नहीं लगती है ना, बेवाक जो स्ट्रेट फॉरवर्ड है. See, I am not a philosopher, I am a coach. I have to bring best out of you people. That is why I speak straight. I do not speak like Vikas Dibyakirti and Avadhoja. Comforting illusions created in the mind of students. That illusion could be created by me also if I leave this one. सिलेबस में तो कुछ भी नहीं लिखा हुआ है. सिलेबस में कहां लिखा हुआ है कि आपको लोकल बीन्स से क्वेश्चंस पूछा जाएगा. बीन्स लिखा हुआ, देयर आर क्वेश्चंस, मल्टीपल क्वेश्चंस फ्रॉम द लोकल बीन्स. आगे चले. माउंटेन एंड वैली ब्रिज. This is mountain top without ice cover. Mountain and valley bridge are generated if the mountain top is without ice cover, and this is surrounding valley. You know that the air is thin and lighter at mountain top. Air is thick and denser above valley floor. It is clear? This is the atmospheric top. Now select daytime. Which place is going to receive more sunshine? Mountain top या valley floor? Mountain top, because here air is thin and lighter. So here is high sunshine, high solar insolation with high temperature. That is source of here low pressure. And here is low solar insolation with low temperature and high pressure. So wind is flowing from valley to the mountain. That is called valley bridge. Because here air is thick and denser. So scattering of the sunlight, yeah, solar insolation is going to be greater above valley floor compared to the mountain top. Getting this thing? Alright. Now comes the night. अंधेरी रात. नहीं, अंधेरी रात आएगी. अब मजा आता है तुमको? ज्योग्राफी तुम सीख लो ना, पढ़ाना शुरू कर देना नेक्स्ट बैच से. अच्छा रहेगा ना, मुझे थोड़ा सा आराम मिल जाएगा. पढ़ाओगे? बड़ी ध्यान से सुनता है भाई. Now comes the night time. That is the time of outgoing terrestrial radiation. From the surface and atmosphere to outer space. Where outgoing terrestrial radiation, which is the source of cooling of surface and atmosphere of Earth, is going to be rapid. From the mountain top, yeah, from the valley floor. Top, because again here is thin. Terrestrial radiation has to cross thin layer to go to the outer space. And here terrestrial radiation has to travel through thicker and denser atmosphere. So remember that in the night it is going to be cold and denser. Here air is going to be warm and lighter. So the wind will flow from mountain top to the valley floor. That we will call mountain bridge. So where fluctuation of temperature is high, variation in temperature is high according to day and night. वैली फ्लोर विच इज ए लोलैंड या माउंटेन टॉप? माउंटेन टॉप। तो इसका मतलब है यू कैन डिराइव ए रूल, फ्लक्चुएशन या वेरिएशन इन टेम्परेचर is inversely proportional to thickness and density of air above a place. If air is thick and dense, fluctuation या variation in temperature is low, like here. And if thickness is high, density of air is high, thickness is low, density of air is low, fluctuation या variation is high. It means that, further conclusion, if the earth is devoid of atmosphere, there would have been much greater variation in day and night and the summer and winter season. Without atmosphere, earth would have been extremely hot during day and summer season and extremely cold entire earth surface during night and winter season. This is how geography is done. People have created rumor about the geography because they don't understand the basic rules and the derivations. देखो इसी से हो जाता है कि नहीं. This point can be included into the question which are asking about short term temperature variation. This point could be also included over there. It is clear to you people? Shall I go to the local winds? Now, local winds. Are also described as tertiary wind. Now their geospatial temporal property means area they cover is going to be small, time over which they are flowing is going to be short. So they must be product of localized surface and atmospheric conditions. Localized surface and atmospheric conditions. That is why their coverage is small. Duration of time over which they flow is going to be shorter. That is why these are called local. So, scale, understanding of scale is very important. Something which is global is called planetary. Something which is regional is called regional. And something which is local is also called micro. So, which winds are going to be dominated? Local or primary? Primary winds. They are nearly covering the entire planet. Which language is going to be dominant? Local? Yeah, global. Like English, French, Spanish, Spain, Portuguese. During the colonial period, of course, even though today English dominates in terms of the business education. So which language will face endangerment? लोकल लैंग्वेज या ग्लोबल लैंग्वेज? इस तरह से क्वेश्चंस हैं ह्यूमन एंड इकोनॉमिक ज्योग्राफी में. यही तो होता है अंडरस्टैंडिंग. एक बार अंडरस्टैंडिंग डेवलप कर लो, कोई भी स्टैंडर्ड बुक पढ़ लो, यू कैन राइट योर आंसर. That is why I am not giving the printed notes, third class printed notes. I am asking you people to read books. क्लास में आपने समझ भी लिया है, एक बार बुक्स में जाके उसको पढ़ लो. Some points if you are not able to understand, ask me. अपना नोट्स बनाओ, किताब पढ़ो, उससे बनाओ, तब ना you will top. You people want to be at the bottom or at the top? Choices are yours. Bottom is like reading PDF of everything. Bottom is that ignoring the facts and truth. Bottom is like without reading a textbook, going for the test. Bottom is सोसाइटल इमेजिनेशन एंड फैंटेसी. हम घर से चलेंगे, पहले बार में ही टॉप कर लेंगे. अरे मिनिमम ड्यूरेशन ऑफ टाइम ऑफ प्रिपरेशन इज रिक्वायर्ड. इट इज वन ऑफ द टफेस्ट एग्जामिनेशन. तुम लोगों को बुरा लगता है ये सब बातें बताने में, इसलिए बता रहे हैं कि तुम लोगों का लंबा समय ओल्ड राजेंद्र नगर में ना लगे. शुरू से ही कॉशियस रहो अबाउट द सिलेबस एंड पीवाईक्यू. नाउ लिख देना. नाउ क्वेश्चंस आर लोकल विंड्स. कितना टाइम? आ जाना, मैं बता रहा हूं. $72. बहुत सारे क्वेश्चंस है लोकल विंड्स. See, questions are not from the primary or secondary winds. To surprise students, they are asking questions from the local winds. So, for a student preparing for civil services, local could be as important as the global. Local is as important as planetary. Got it? एक ही है, बहुत सारे. 30 लिख लेना, 41 लिखना, 41 आगे कर दो, मन करे तो प्लस. With suitable examples, bring out the impact of local winds on the climate of an area. एक 2007 में भी है 25, आगे कर देना, नीचे ही लिख दो, लिख दो. So these are the questions related with the local winds. 15 minutes we have. Shall I start? Some of the winds we can discuss. So remember that I have given the definition of the local winds on the basis of thermal properties. Local winds are classified into two categories. Cold and dry local winds. Today I will cover cold and dry, and hot and dry local winds. Cold and dry local winds. These are cold and dry. And these are source of producing snow and cold wave conditions. And their source is covered with ice caps, ice fields and glaciers. That is why they are cold and dense, as their source is covered with either ice caps. Larger mass of the ice covering a larger area is called ice cap. A smaller mass of ice covering a smaller area is described as ice field. Like if you go to the Badrinath, you can see the ice fields. With the melt of ice, size of the ice is reduced on the surface. And then glaciers are downhill movement of the mass of ice. River of ice is known as glacier. So cold and dry local winds are cold and dry. They are source of generating snow and extremely cold conditions known as cold wave conditions. So these winds are also source of variation in temperature. Now, these winds are known as blizzards. You people must be knowing blizzards are source of massive snowfall. And blizzards originate from polar ice caps and glaciers and high altitude mountain tops. Covered with large ice caps and glaciers. And blizzards are source of massive snowfall. Particularly in North America and Eurasia during winters. And that phenomena is described as snowgilla. If the snowfall is massive, 3 to 4 feet of the ice is falling on the surface of earth, accumulating, that is called snowgilla. This snowfall is source of landslides, landslides, avalanches, downhill movement of mass of ice, instantaneous, is called landslide. Landslide I will teach in geomorphology. Downhill movement of a huge mass of ice is called avalanche. And related, death and destruction. Interference into the movement of the people. Loss of life of the explorers, climbers in high latitudes of polar regions and high altitude of the mountains. Some of the movies on Mount Everest showing tragedy with the climbers, you people can see how blizzards affect their life. It is clear. Some of the cold winds, which are cold, dry and source of the cold waves, also originate from the mountain tops during winter season with the snowfall. And one of the example is cold wave in the Great Plains of India, outflowing from the mountain tops of the Himalaya during winters with the heavy snowfall. Greater is the snowfall, greater is coldness, greater is the shivering produced by cold waves, that is called शीत लहर in Great Plains of India. इसी को कनेक्टिविटी बोलते हैं, इसी को लॉजिकल कंसिस्टेंसी बोलते हैं. Another wind is known as Mistral. It is a wind with the cold wave conditions flowing into the Rhone Valley, R-H-O-N-E, Rhone Valley of France. Rhone is a tributary of Rhine. Another is Bora. These are all originating during winter season with respective snowfall on their mountain tops. It is along the Adriatic coast of Italy and Greece. And Pampero in Argentina. So these are the cold wave, cold and dry winds originating from mountain top during winter season with heavy snow on the mountain tops. So these are the example of cold and dry local winds. Blizzards are source of heavy snowfall, great amount of snowfall. Unexpected amount of snowfall is source of the landslides on the slopes, avalanches on the slopes, death and destruction of the mountain camps, base camps. Remember that cold wave conditions are also source of hypothermia. ये सब भी लिख सकते हो, कॉमन सेंस वाला. Hypothermia. That is why during the winter season, shelters are created, constructed for the poor people. Cold wave conditions are also source of death of the people, death of the birds, animals. Cold wave conditions are also source of destruction of certain crops like wheat during the winter season, because cold wave conditions are source of generating frost. Frost is injurious to crops, पाला जिसको बोलते हैं. जिसको पाला बोलते हैं. So thank you all. Tomorrow we are going to study the next topic.